Okay, we were discussing the ammeter. We said the ammeter is a kind of instrument that reads the current in the circuit. Here I'm going to show you how an ammeter looks like. Okay, probably at school you will see these. These are a bit old-fashioned. They are called analog. They will show you the reading with the needle. But nowadays these are more widely used, which is digital. So the others are analog, the old ones, although they are still available. But nowadays, usually the ammeter, it's this kind of instrument which is shown in yellow. It contains two wires. Those two wires are connected to the circuit, and it reads the circuit at that particular point how the current is flowing. Like we were saying, I have a car battery and I need to know if the battery is failing or not, and I have to read using an ammeter. So the symbol for the ammeter, as we said, is quite straightforward, a circle with a letter A. So we're going to read ammeter reads current flow to be connected in series. Okay, very good. So next item, another instrument is the voltmeter. Again, the voltmeter is drawn just a letter V inside the circle. As with the ammeter, as we said, it reads the current. For the voltmeter, it reads the voltage. Okay, to be connected in parallel. I'm gonna explain again in series and in parallel what they mean. Okay, the voltmeter, it looks the same as the ammeter. Okay, okay. Usually the voltmeter has got a letter V as you're seeing over here, while the ammeter it's here it's got the letter A. Okay, A for ammeter and V for voltmeter. Okay, of course the voltmeter nowadays is incorporated as one instrument. So if you happen to have this kind of instrument, which is this, usually there's the knob over here in the middle, and you change what you need to read, either as an ammeter or either as a voltmeter. So basically nowadays, one component, one instrument, it is used for more functions. Okay, these are the needles over here. Look, these two needles are connected with the circle, and the digital will give us the reading. Okay, it is very, very important. This is a description lesson. Do not try these components. Alright, always ask an adult or a qualified person to show you these items. Alright, as I said, this is a very dangerous business here, so important. It is nice to learn these components and I'm show you how they look like and everything, but if you're interested and you want to get into more details, always ask a qualified person. Never try or explore things on your own. It is very, very important. Okay, so let's move on. Now we're gonna tackle some kind of switches. Okay, so here we have what we call an open and close switch or toggle switch. The switch is like a gate, it's very easy to draw, like we've shown on the design here. This is a normal switch we use in everyday life. For instance, to switch on the light in our bedroom, the light in the kitchen, and even, for instance, the light in the car. If I want the headlamps to go on, I just turn the knob. So that is a normal switch. Okay, open and close switch. Next switch is a bit different. This switch is called push to make switch. Push to make contact. Alright? So this switch, to give you an idea, if you push it, it makes contact. But as soon as you release it, it stops making contact. Alright? To give you an idea, for instance, the hand tools for safety. Okay? Let's say you have a driller, you have your finger on the knob of the driller. As soon as you press the handle, the knob, it will start working. As soon as you take off your finger from the button, it will stop working. So in that case, it is a push to make switch. All right. Another application, to give you an idea, is it is wisely used in apartments, where when you're going up the stairs you will see a switch, you push it and the light, it will go on. After some time, because this switch is with the timer, it will go off, so the light, it won't remain on all the time for nothing. Okay, so push to make, as soon as you push the switch it makes contact, as soon as you release it, it will stop making contact. Okay, so this is how you're gonna draw it with a letter, like it's like a letter T upside down. It shows that it only makes contact if that switch is pushed downwards. Okay, so next kind of switch, this works in the opposite way. It's called push to break switch. Okay, push to break contact. Basically the switch is very used, although main probably you're not aware of. To give you an idea, if we were in the classroom we will ask and do a discussion about this, but here the time is a bit limited. So basically push to break switch, to give you an idea, is the switch we have in our fridges at home. Okay, as soon as you close the door of the switch, the light inside it goes off. As soon as you open the fridge door, the line, it will go on. If you notice, there is a switch on the side of the fridge, so if you push it, it will go off. If you release it, it will go on. So it works like in opposite direction. Okay, another application is again the car. When we close the door, the lights will go off, the internal lights will go off. When we open the door, the lights will go on. So if you notice the car, there will be a switch hidden somewhere. So when the door pushes that switch, the lights in the car, it will go off. So that is the principle for to push to break switch. Okay, so here it's written push to make contact. Oh, sorry, push to break the contact. It works in the opposite direction as the previous switch. Okay, so next component, here we have a transformer. Basically it's a bit strange how we design it, but this is representing the circuit, and this, the lower part, is representing another circuit. I will do it like this. I will write it down. I'm gonna write circuit A and circuit B. I will explain why. Okay, so this part